Hello, everyone. Good evening from Japan. It's probably early morning for many others here. I'm Norbert Preining from Fujitsu Research, and I want to guide you through my personal playing around with graph database and representing TeX life and TeX life history of more than 10 years in a graph database. So here, let's go. So first, for those who might remember TeX or LaTeX from school or from high school or university or other times. So first of all, don't panic, please. Yeah, this is not what I'm talking about. You can also imagine some large and friendly letters there. So it is TeX, it's about the TeX life. I will talk about the distribution and what it is, but we don't make a TeX course, so don't be scared when there are strange symbols here. They will be only on the first slide, TeX related stuff. Okay, so a bit of the program for tonight. I will do a self-introduction, getting a bit you to know what TeX life is in general, and what the TeX life packaging system is. And then I switch to how to represent our packaging into a graph database or into graphs, and how to transform it into Neo4j. So it's less of a finished product, but well, product anyway. I mean, everything in TeX life is volunteer work. So, but more like the process how to get this amount of history into a database. And we'll finish up with some ideas or what I had. So first of all, about myself. So I'm a mathematician by education. I'm a computer scientist, mathematician, mathematical logic. So what you see here is an example of some proof theory. So I hope you are not too scared. I worked originally from Austria. Then I lived in Italy, and since now I don't more than 11 years in Japan. First at the Geist, then another company, and since some time at Fujitsu Research. I'm also a TeX life developer. I have been responsible for the whole infrastructure, the TeX life manager, the security stuff, everything that ships the packages we prepare to the user and, well, make them usable there. I also am, since, I don't know, 20 years, I'm a Debian developer, responsible not only for TeX, but also since some time now also for DKD Plasma Stack, so the graphical user interface, but also for machine learning stuff. Where I'm interested is in Julia, the Julia language, and for supporting, well, kind of GPU computation on the AMD hardware, the ROCm stuff. And if I'm not sitting in front of the computer, I spend my time sometimes in the mountains, or take as much as possible in the mountain. I'm also a professional mountain guide, doing all kinds of activities. Okay, so what is TeX life? So I think we probably first have to say what TeX is. Yeah, as I promised you, you won't see more code. So TeX is a typesetting language. You feed in text, and what comes out is something what you normally print in a book, into a report, into whatever, or you display it online. In what kind? Most popular nowadays is PDF format. So it was devised by Knut, and yes, it is the Knut from AOCP algorithm. The Knut who I think it was the head of Microsoft, right? Who said that whoever read all the books, also the AOCP levels from Knut, can immediately enter into the company. And it was originally released in 1978. It has done quite some development since then. Just one hint, Adobe, like a few years ago, with Big Dum Dum, celebrated the introduction of a paragraph formatter for text, so that you look not line by line like Windows Word is doing, no, but formatting it, breaking lines according to the whole paragraph. Well, that was open source 30 years ago by Don Knut. It was Adobe who was a bit late. It has superior mass typesetting, but I used it, for example, for Tibetan language or other language, all kind of different things, chemical typesetting, music notes for my piano lessons. And so it can be done for all kind of stuff. So what is TeX Live? TeX Live is the biggest distribution of TeX. Maybe some of you who had contact with this know about TeX, TeX, Thomas Esser TeX. So that has Thomas Esser stopped development already many years ago, and TeX Live is nowadays practically the only distribution besides Windows-specific MikTeX. It ships all kind of programs. You don't have to know them if you're not interested in TeX. All kind of data packages, font, macros, LaTeX, all kind of stuff. And the management of all the packages is done via the TeX Live Manager. So what are the features? It is big and it's complete. So we try to include all the free stuff from the comprehensive TeX archive network. So an installation of TeX Live now is about 8 gigabyte, 7.5 gigabyte at the moment, which is for a software package rather heavy, I would say. It's also multi-platform. We'll talk about this a bit later. We try to be uniform across platforms. So if you work on the old AIX or onto Mac or Linux or Solaris or Windows, we try to provide you with the same environment. We have their own package manager, TeX Live Manager, which was written by me. And nowadays we have practically daily updates. And yeah, it's also DFSG, so Debian Free Software Guidelines free, with a few exceptions about documentation. Concerning not really core, but multi-platform, for example, Go language is often shown as one of the multi-platform. None of these multi-platform packages actually support nearly what we are supporting. This is what is currently officially supported. We have other architectures that have dropped out or are not really completely supported, like MIPSL on IRIX and this kind of stuff. History, it is also long. Actually, I realized today that it's exactly 25 years to this day, to this year, that the first release was done by Sebastian Ratz in 1996. I joined somewhere in the 2000, I don't know, 5 or something, 4. And I think 2008, I rewrote the complete infrastructure so that we can go to online internet updates. Before it was distributed via DVD once a year. No, next page. Yes. So what is the TeX Live packaging system? So as I say, we have 8 gigabyte of software. We don't necessarily want to ship everyone this 8 gigabyte. And if we, as I said, we have daily updates, you don't want to download 8 gigabyte every day, again and again. So everything is split into smaller packages, and there is a certain hierarchy in it. So at the top we have TeX Live, so that comprises everything. On the top level we split it into schema. There are only 9 schema. It's just something like medium, small, large, everything, or what more or less what TeX provided or specific for some environment. Then collections are very important because they try to collect related packages, so related font packages or language packages, or like, for example, scientific mathematic typesetting, or languages are a lot. And then below these are packages. So every single package is like more or less one developer. Someone creates a TeX package or a font package and uploads it to the CETA network, and that becomes one TeX package in our TeX Live system. We have at the moment like about 4,000 of these packages, with about 200,000 files in all. And that's all across 16 architecture OS combinations. So this is these 3 levels. As I said, schema is the top level, which can contain or can request or depend on other collections or packages. It is rather a wild mixture on the schema side. The collections try to group related packages. Also, what is important is that the collections, we as well, this is one of our promises, that they form a partition of all the packages, so there's nothing is contained in two collections. This is important for packages, for distributors of Linux, Debian, SUSE, Fedora, because they don't want to have file conflicts. And on the most basic level, we have packages, which is the basic unit, is more or less what's going on. Okay, so how these packages are defined, as I say, I don't show you the content. It's more about how, like the DevOps or how the packaging stuff. So what I implemented back then, 15 years ago, is it was very close to what the Debian package list, stanza is it called, stanzas called. So you have one paragraph, so to say, for one package, and then you have like the name, a revision number in our central repository, a short and long description, and then what files are contained. This is more or less for a simple package. Then for collections, there is just a description. For example, collection Lang Japanese is just for Japanese language support. And it requests a few packages, says depend on a few other packages, but also on other collections. So there are relations between the level within the same hierarchy, but also to the lower level. And schema is more or less the same as the top level. It's like medium schema, a reasonable selection of fonts and packages for some languages. So how to represent all this into a graph database and how to transform it? I mean, this is also an interesting question. So there's what I was struggling for quite some time is what kind of modeling I want to do, right? So for me, there are two types of modelings. One is the famous, what we often hear is digital twin, right? So you model what is there, right? You model the actual state, right? So how it is implemented, or like that all the processes can be mapped over. But there's also a different thing. I'm aware of a better word for this. I call it the specification twin. It's where you start from the beginning and say, okay, what is the ideal state? What is what I want to achieve? So if I would start a new application and a new database, I would start from that side, of course, and not from the other side. So how to distinguish between these two? Well, it's very simple. Ask yourself what you want to do, right? So if you have the digital twin, then you have a current system where you want to analyze the state. You want to analyze, you ask questions about what's going on. And as I mentioned before, for the specification stuff, it's like you're setting up something from scratch, from new. And that's nice because you can encode certain rules, certain qualities into the structure of nodes and relations already. While if you just map it from the available state in the digital twin, then you cannot enforce them because, well, there might be bugs and errors, which you also want to represent somehow and then find them. So in TeX Live, so what would it be? The digital twin would be, well, we have an implicit hierarchy so that every stanza, what I mentioned before, so one package is just, well, one package, one node, so to say. And we have certain additional attributes that tells you this type of unit node is a collection and this type of unit is a package, but no implicit enforcement of order and this kind of stuff. While with the specification twin, that would be nice, is like you have different categories of nodes, and then the relations between them are enforced, that they are only between certain node types and not between arbitrary. So that enforces a certain structure that, of course, would help you. So why doesn't it work? There are several packages in TeX Live that have something like this, where whatever package depends on something higher up in the hierarchy, right? So actually what we don't want is that a package, something depends on something that is higher up in the hierarchy, because this is something how an inversion of the hierarchy, and that is, well, if you have an implicit. So what at the end I tried out a few of them. What I did is somehow a middle way, strange. So I used different node types for the various classes, as I mentioned before. So different categories, but I didn't force the hierarchy. So the relations between all them can be arbitrary. So between any of these types, package, collection, schema, there can be in all directions can be relations. So I allow this, and that helps with queries in searching, and but also capture problematics, also problems in the actual database that can later be found via graph queries. So what are the nodes? It's very easy. So we have one node. This is TLPDB. So this is TeX Live Database, TeX Live Package Database, actually. There's only one instance at the moment. We will go to 10 years later. It has no attributes at the moment, right? We just represent one day, one slot, one state of in the time for now. And then we have what we call TLP objects. This is what we call distances. So in the Perl, in our implementation, these are called TLP objects. They can have schema, collection, package, and they have just an attribute of name. And then the files are the files are represented as their own node type with just the name stuff. And what are the collections? This is rather easy. So we have contains. So what is contained in a database? These are all these TLP objects. These are all these objects, either scheme, collection, or packages. This is very much what we actually have implemented on our, well, it's everything written in Perl. And then we have depends, the relation depends or edge depends. This can go between arbitrary scheme collection package and a scheme collection package. We are completely free here. And we have another relation includes that is just how to get which file is included in a package. It has an attribute type. You might have not seen it, but we have a distinction between run files, so actually needed for running, documentation files, and source files. And you can also install them separately. So we separate them, and this is the attribute. So how to actually go from this database, also from the TeX Live database, which is a few megabytes, I don't know how big it is at the moment, to the Neo database? Well, it was a bit of Perl scripting, which is not so hard because we have good Perl documentation and modules. Export everything to a CSV, comma separate files, and then import it with Neo4j admin import. That works excellent, easy. So what do the package look like? Well, it's just the list of the names, because we don't have any attributes. Just throw in the header, name, and ID that the Neo4j admin import knows that is the ID for later for the relations. And for the relations, we have, well, just the start and the end ID, just, yeah, which the relation between these two packages identifiers. And for the includes, yeah, well, we just have which package and which file, and then the type. Here we have quoted because, well, spaces as usual, right? Spaces in names. So import is rather easy, straightforward with Neo4j. I will show you later how to import this. It's on my computer. It took like 2 seconds or something for importing like 70,000 nodes and yes, whatever, what is there. There are a lot. I don't do live here. I could, but that is too dangerous. A few queries, not very intelligent one. Give me all the schemata. Give me all the collections. Check for consistency. This is something what is important for, as I mentioned, for distribution, that no package is included in two different collections. This is something which creates big problems if you package this, like I'm also responsible on the T-band side. So this is something I really want to have, and actually there are failures. If you go over the history, there are several times when this was not correct. Check there are no cycles, that we don't have cycles in the dependency change. Also this is something we want to have. Also, files are not included in multiple packages, because again, that creates, on the TeX Live side is less a problem, but for distributors this would be a problem. So all this can easily curate with a graph. trivial things like return all the type or documentation files. Here we use this attribute of type of the includes relation. You can do also typical graph algorithm rank, whatever the Google rank for the package database. You might need just for the fun of it. Betweenness is more of an interest that gives, of course, the central part, which not surprisingly gives you the most basic collection. The collection basic in the center is the most important because it's required from all sides. So it shows quite a good structure. I mean, I cannot show all the rest of it, but it's a straightforward. Okay, that was for one day, right? That was one day. But actually what I'm interested was, of course, first I was interested in doing it in this way, but then I wanted to look into the history. So what history is available? So Take Life is an old project. We started with Perforce. I'm not sure if anyone remembers. It was once used by the Linux kernel, and we also used it for Take Life. We switched then, I think in 2009, to Subversion. And we still use Subversion. So from the old times, from the Perforce times, we only have the logs. We don't have anything carried over. But we have from 2009 on, we have the Subversion. It's all. It's also required by our scripts in Subversion. I have made my own playground because I'm not really fond of Subversion anymore. So I made a Git SVN clone, which I manage and publish to my own server because GitHub doesn't allow to push 50 gigabyte of Git repository, but it is available. So for people who want to play with it, I use it daily. And with the Git, it is very easy to get history out of the old files. So typical things why we would be interesting is things like how did the number of packages increase over the years, right? I mean, this is a graph that was very easy to get from the database. You just go over all the database and packages and count, right? And order it by date, and well, then you plot it in whatever way. This is a standard increase. Also the files, this is a peak I don't understand. So this is the increase of files, quite straightforward, of the life over the last 12 years or something. It's also, as I said, for packaging, for distribution, having consistency checks that we don't have problems for all the times. And also because it's fun to have all this kind of stuff around here. Because I'm the maintainer. So how to represent this? Well, we have this hierarchy, this pyramid. Well, the problem is now we have 10 years or actually more. Well, they have lots of them. Well, actually, around 3,600, maybe more, maybe less. That is, by the way, also the reason why the database is not publicly available anymore on my server, because it's just when people playing around with this, my server, which is not very strong, could a bit crumble. I had the first, for a single database, I put it anonymously on my server to be accessible, but nowadays not. So how to change the database schemata? Well, schemata, where we know it's graph database are schema free, but still, I mean, what kind of nodes and relations you are putting in from the very beginning? Well, it's just add revision numbers to all the entities and add next relations between the steps, between the days. It's more or less on a day. We sometimes have several days no database and sometimes several per day during release cycles. So the new nodes, the nodes remain the same. It's just that the database receives a revision, a date, just for adding, so date time, and whether it's current, a binary flag, what is the most current now. The objects just receive a revision, additional attribute revision number, which is, in principle, it's the highest revision number in the Subversion repository, and file stays the same. And from the edges stay all the same, nothing changes. The only thing that is added is the next operator that just gives you, well, the next day or the previous day, whatever, in which direction you want to use it. So that actually shows how it's nice that you have something represented, a certain structure, and then you want to add history, some timelining about this. It is quite easy to extend a graph database in this way without too much rework. So what were the requirements from our side? First, it should be incremental, right? I mean, you want to stuff in new data well, every day you want to stuff in new data, not create everything in one go, because then it grows. Then also we don't want to duplicate data. That is something that happens quite often, because the same package, revision package, if it is not updated, then it stays the same, right? Sometimes for years. We have packages since 15 years haven't been updated. So they should be only one node, right? Nothing changed, right? So you don't want to have multiple copies of this. And then we want to store this temporal sequence. And we want to allow easy access to the most recent database. So that's what I mentioned already. So how is this all done? Well, it's very easy. Again, I didn't write here actually. First with Git, I just checked out all the databases, which amounts to a lot of disk space. Convert all of them into CSV files again. Actually, slightly different format, because why? Because the Neo4j admin import, what this tool expects for import and what, like when I create cypher queries, is slightly different. So the CSV files is slightly different. Then one of the very important things first you generate the initial database, is like what we've seen before. Then don't forget, I sometimes forgot, don't forget to create indices, because otherwise everything crawls to a halt. And then I generated update for every day, just the update cypher statements, which I fed into the database. So how do these initial files look like? They look very similar to what we've seen before. Well, name is the ID, and now we have the revision number in integer here. The database has current as a Boolean and date timestamp. Neo4j now, so since quite some time now, supports very good time and date functions, and the revision number. And the edges remain just the IDs, which are the names, because they don't. Actually, this is this is for the import, right? This is for the initial. And then I haven't shown you this in the beginning. You just kick down this Neo4j admin for every collection, node, files, and the relationship. Quite easy, very fast. How to do with the daily update cipher? This is a bit more tricky, of course. Well, and again, generate CSV files. Well, just name revision for all the packages. Then for the depends, I just package version. This is the relation. And then I load them from, in Cypher, I can load CSV files with headers, and then you can reference these keys here and just merge the package. So the merge makes sure that you don't duplicate the nodes if they're the same. And the same also with relations. Of course, you trick around here a bit. Normally, you don't do this straightforward, but you do periodic commit adjustments. Otherwise, it's getting too slow again. So if you have a stable system, then you can pump up the periodic commit to high values, which makes it much faster. Okay, what comes out? Okay, it's a graph database conference. At least I have to show one graph. So this is only a very small part, of course. This is actually a slight problem for me, because I just use the Neo4j browser, because I don't have any special products here. So it's rather, so expanding relations always ends up in billions of nodes suddenly appearing. So getting only a few nodes of them is really handwork to get this doing. So here we see a database, here we see schemata, and we see two collections. And for one collection, I've put also the necessary packages here. So that, well, actually there, of course, there are many more, but I showed only a few of them. So what are typical questions that I have asked this graph, or what I curious about this? So one is, for example, the most updated package, right? So we have packages that, especially recent in the last 2 years, get updates every second day or something. What is the average update rate per package? Then what is find moves of packages between collections. So if I package a certain version, a certain checkout for Debian, I have to be sure that when packages move between collections, that things have to be adjusted also on the Debian side. So these are things that are quite important to find out for the packaging. Also something that I haven't, I have looked into this, we haven't followed this by now, would be interesting to find high and low activity times. So times when there are a lot of new packages or a lot of updates, and adjust our release schedule to that. I'm just scared if we announce a release schedule, then again, everyone will be very busy just on the last 5 days before release, because that's always what's happening. But if everyone would just continue, that would help us immediately. Also, I haven't added by now, it's easy adding size information. Size is a file size, and so after having added the ciphers, you can of course average size, outliers, really huge packages. We are now kicking the border of the DVD distribution, which doesn't fit everything, because we distribute several things on one DVD. It's already, we have to cut out stuff, and that gives, so GraphAlgorithm would give us here a way to optimize what is the smallest part we can cut out without severing too many dependencies. And yeah, so that's some of the ideas we can do. Also, this is something ongoing, and that is something I really want to do, is getting dependency information. It's really hard because there is no automated way to detect, well, okay, I have written half an automated way, and it should be a bit better. So enriching real dependencies between packages. So, and then to find like subgraphs, collections that are actually connected. So in the sense connected, that they are content-wise, so they are all related to a certain language or all to drawing graphics, and include also all the necessary packages. So somehow to get subgraphs, because that is often a complaint onto the database, onto our splitting system, that it is not optimal, right? And I agree it's not optimal, but nobody could come up with a better system till now. So I really would like to find something better. Some conclusions. What I was interested, but what puzzled me most actually, is that, how to represent timelines. So what I mentioned here is, so we have very good support for date time, timestamps, all in Neo4j with all kind of computations, functions to extract. So that is easy. And it's very natural for graphs. As I said, everything there is a natural representation is a graph. But I haven't seen, maybe there is, I haven't seen, there are a lot of, let's say, libraries or products for like time series, but there's nothing what I would like to have. You represent a certain structure, and then you just develop the structure over time. And I want to have this timeline over the structure with an easy way to just duplicate, but not only really duplicating, like we didn't duplicate here. We want to keep unchanged things as a single node. And we want, what would be nice is an easy way to separate queries into certain sub-branches, like to say restrict to this database and this kind of stuff. Of course, you can do this with deep dependency, with deep connections, but this makes the queries quite heavy. So something like subdomains, that is something I haven't found. Some things I have learned, representations are hard. I have changed representation a few times over the last years. I have actually a new one, half work in progress, half finished, where I have used multiple categories for nodes. That makes it easier for, I don't know what has changed. That makes it easier for queries if you have, like, say, a meta category table object. And of course, Neo4j admin versus CSV import and all these differences. I mean, most people are aware of this, but if you do it the first time, then, or not the first time, but then it's a huge difference. And last but not least, because I always forget this, never forget the indices, because without them, I mean, I have recreated this database a few times over the last months, and sometimes I forget the indices and then nothing works. Okay, that was all from my side. I think as far as I see, I'm on time. Thanks for your attention, everyone. I think after another talk will be a Q&A session where I'm happy to answer any question from your side. Thanks a lot.